Alright, hi, good day everyone. So today we are going to be doing January 2025, number 9, which is our geometry and trigonometry question. So let's go right into it. The diagram below shows a circle with a center O and point P, Q, L, an N line on its circumference. LN, and N and Q are equal. So these are two. So basically we can see that this triangle here is an isosceles triangle because their sides are equal, right? And RM is a tangent at the circle at L. So immediately we know there's a tangent meeting our diameter. So therefore that is 90 degrees, right? This is 90 degrees. Here is 90 degrees. Angle MLN is 63, right? So when I look at something like this, my mind is going to go, if I have two angles, this angle here and this angle here would be equal because they're produced by the same chord, right? Let's just so the theorem is angles at the circumference of a circle on the same arc or chord are equal. So I would, I'm gonna type it out, make this a little bit smaller. Angles at the circumference of the circle, angles at the circumference of a circle on the same arc or chord are equal. So you say angles at the circumference NPL and NQL of a circle. Angles at the circumference NPL and NQL is on the same arc. It's not an arc, let's call it a chord. What is the name of the chord? NL. Hence they're equal. We haven't calculated it, but I'm just saying that is a rule, right? The next thing we would say, we see a diameter with an angle opposite, with an angle opposite. So we would say the angle in a semicircle is a right angle, right? So copy. So the next rule is the angle in the angle P and L in the semicircle is a right angle, so therefore that is 90 degrees, right? And the what makes it a semicircle? Because we have a diameter PL, right? So basically the side that is opposite the diameter, the angle that is opposite that diameter is 90 degrees. So that is how I know that this angle here is 90, right? We also know that isosceles triangles have two equal sides, hence the base angles are also equal. All right, just leave a space in between it so that so the isosceles triangle is L and Q have two equal 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 sides. The two equal sides they told you was LN and NQ. Hence the base angles. What are the base angles? The base angles would be NQL L and NLQ are also equal, whatever they may be. Alright? The next thing that I can see is they said a tangent. So tangent MR meets the radius. We could call the radius OL, or diameter PL. But let me just say meets, intersects. Intersects the RADI radius OL or diameter PL at 90 degrees. Right, anything else? No, that's about, well, we know triangles are 100. Hold on. Triangle P and L is equals to 180 degrees. Right? Okay, let's see. These are your explanations. Let's see what the question says. Explain why X and angle NQL are equal. I already have that there. Angle X is also known as NPL. So this is X. Are equal because they lie on the same chord and L. Alright, so I'm just going to copy. Paste it right here. Right. Then we have, let's zoom up. Determine the value of each of the following angles. Show detailed working where possible and give reasons for your answer. They want angle X. So first off, let's find out a few things. Let's write out a few things. Right? We know that from here to here is 90. So therefore this angle here would be 90 minus 63. So it's 27. Right? We also know that this angle here is 90 degrees. What else do we know? This is 90, this is 90 here. Can I calculate for this angle here? This is 27. Right. Okay. So angle X would be calculated by saying 180 degrees is equal to 90. Sorry. So I would first start off by saying, right. So say determine the value of each of the following angles, show detail working where possible. So immediately, remember we had that this right here, the tangent MR intersects radius OL at 90 degrees. Let's make this a little bit smaller. Then you would say that angle PLN is equal to 90 subtract 63, right, which is equal to 27. Then you would say X plus 90 degrees. Why 90 degrees? Because that's P and, let me use my letters. P and L plus NPL plus PLN is equal to 180. What is P and L? P and L is 90 degrees, right? Why? Because of this reasoning here, the angle P and L is 90 degrees because it is in the semicircle, right? So P and L, which is 90, plus NLP, which we found out to be, is this NL? Yeah, or PNL. PNL or NLP, whichever one you want to call it. Plus 27 plus X, which is PLN, is equals to 180. Right, so X would be equals to 180 subtract 90 plus 27, which is 117. So 180 minus 117 is equals to 63. So X is equals to 63 degrees. Now that we know that X is equals to 63, immediately we know that if this is 63, this one would also be 63 because they are on the same chord NL and they are at the circumference, right? So you're supposed to put your reasonings here. I put it there, but that is how you would do it. Angle Y. So if this is 63, because again, therefore this would be 63 because they are equal, then angle Y would be 180 minus 63 plus 63. 180 minus is equals to 54. So the first thing you're going to have to put your reasoning for angle Y is you're going to have to put this here, the angle at the circumference of the circle are equal. So if that angle X is 63, which we calculate just now, so angles at NPL, which is X, is equal to 63. So therefore NLP would also be 63. Right, then we are going to say this is 63. We would also say about the isosceles triangle that the bases are equal. Angles at the circumference. So the isosceles triangle have two equal sides, and so hence the angle. So they told you that NQL is 63, so therefore NLQ is also 63. We also know that the triangle NLNQ is 180 degrees. Alright? So we know that y plus 63 plus 63 would be equals to 180. Okay, I don't know what happened there. Is 180, so therefore y would be equals to 180 minus 63 by 63 is 126. So when the answer would be y is equals to 54. And that is your answer for this. Right? Axis of, yeah. And is that all the questions that they asked you for angles? Let's zoom out. Yeah. Right, then they have the last part of the question, which is to calculate these angles. So let's just go ahead and do it very quickly. Port E and G are on the level of the ground 245 kilometers apart. So E and G 245 kilometers apart. They're bearing off E from G. So from G to E. So from G to E, always going a clockwise direction. Is equal to 302 degrees. A ship is anchored at F, some distance away from G, on a bearing of, so from G to F, alright, so let's put that, from, a ship is anchored at F, some distance away from G, on a bearing of, so from G to F is equals to 228. Angle EFG, that's this angle here, is 52. This information is shown in the diagram below. Alright, on the diagram above, insert 228, the bear, so I already did that, right? In black. Determine the value of angle FEG. FEG. So first off, we can see this angle G. I don't want to use the black. Let's use green. We can see that angle G here would be the difference between 302 and 228. 302 minus 228 is 74. So this angle here is 74. We know a triangle is 180, so this angle here would be, let's do that in a different color. This angle here would be 180 minus 74 plus 52. That would be 54. So this angle here is 54. So any angle that they ask you, angle FEG, that would be 54 degrees, and that is the max for it. Alright. Calculate, hold on, let's zoom up. Calculate FG, the distance of the ship from port G. So they want FG, so they want this here. So all three angles are given on a side, so we can use sine. So from the information given here, right, let's just FG, they want this side here. Right, we have a side and an angle, and we also have an angle, so we can use sine rule. So we can say this here would be side E, right? this here is side E, this here is side common G, and this side here is common F. We can say that E over sine capital E is equal to, do we have a side and a corresponding side angle? Yes. F over sine capital F. So let's see what they give you. They gave you E. We don't know E, so we're going to put E over sine F. Sorry, E over sine E over sine 54 is equal to F 245 over sine capital F, which is 52. Right, when you carry this across, so E will be 245 over sine 52 multiplied by sine 54. Put this in your calculator. Let me get my calculator to show you how to do it. So 245 divided by sine 52 multiplied by sine 54. Make sure that your calculator is in degrees. You press equal, and E, or side E, will be E slash GF would be 251.5. Is it in kilometers? Yes, kilometers to 1 decimal place. And that is how you would do this question right here. So part 3 says indicate the point at H on line EF such that GH is the shortest distance from G to EF. So indicate the point on H. So point H we're talking about on line EF, this line here, such that GH is the shortest distance from G to EF. So you want to know the shortest distance. Now you can use your ruler to do this, just to see. I hope my ruler don't give trouble, because it does sometimes. Let's just so we want to know the shortest distance from G, so you're going to use your ruler, right, from G to EF. Now if we look at this here, this from here to there is 3.5, so let's rotate it anywhere along. It's getting shorter, it's getting shorter, it's getting shorter, it's getting shorter, and then we start increasing. So it is somewhere along here. Right, I think, yeah, no, anywhere else would be greater. So right here. So the angle there, hold on, not the angle, this is where H is going to be located on EF. Right, they ask you the where it is going to be located, and that is where it is going to be located. That's indicate point AF on line EF such that EH is the shortest distance from G to EF. Determine the distance of EGH. So it is a 90 degrees triangle, right? So this here is a 90 degrees. So the shortest distance will be a 90. So this is 90, this is 90. Now they told you, hold on, right, X is off. They told you in the other question they want to know the distance of G to H. So they want to know G to H. This here. So we'll call this smaller. We don't want to call it smaller. Let's call it GH. Right? GH. Right? We know this is a 90 degrees, so this here is our hypotenuse. There's nothing else given in this question other than the angle, and then so we need to find out, right? So we have two 90 degrees. We have this side and this side. If you use this angle here, you will have to find line GF and HF, which is going to make your life significantly more difficult. But if you look at this 90 degrees here, this here is our hypotenuse, right? We have right, so we have the hypotenuse, and we are trying to find the opposite, the side of the opposite, and then we have an angle here, right? So we know that theta would be 54. We know your hypotenuse is equals to 245, and we want to find out GH, right, which is the side opposite our angle. So this is opposite, right? So we will put so, ka, toa, and ask ourselves, which one will we use? Will we use sine, cosine, or tan? We will use sine. Why? Because it's opposite and hypotenuse. The others have adjacent, and we don't know adjacent. Adjacent is G to H, and we don't want to calculate that, right? So now we know that sine theta, which is sine 54, is equals to opposite, which is GH, over hypotenuse, which is 245. You carry this across, so you know that GH will be sine, not sine, would be 245 sine 54. 245 sine 54, and so GH is going to be 198.2 kilometers to one decimal place. And that is how you would find out the side of the length of GH. And that is the end of January 2025.